Yeah. Okay, so thanks everyone. So let me just give everyone a round of applause since 2 amazing days have passed. So I just want to ask, why is everyone here today? Don't know, because we all want to look like the cooler kids, right? Next around using Streamlit. Today's talk, we're talking about achieving concurrency in Streamlit with the RQ scheduler. Even though that title seems a little long, but we will see how this will impact our life quality mainly. So this is some of my fun facts. So I'm a Python, civic tech, open source enthusiast. We have a pretty avid civic tech community in Canada. So the most repeated theme that arises in civic tech is mostly about our public transit system that we need to use technology to improve. Because our Toronto Transit Commission also means take the car. Whoops, did I say that? Well, so some of my Python work projects, including operation research for institutional resource optimization, and some creative use of NLP PyTorch models. I also run Meetup in Toronto since 2015. So our Meetup group is called Public Data Technology Forum. So now we run every other week LLM sessions. So you can feel free to join us online on Zoom. And we also record our podcast sessions. As you see, some of the sessions we run, including tabular data set on LLM and also chain of thought algorithms and so on. So that's enough about me. Let's see what is the agenda for today. So everyone knows Streamlit is great, but sometimes it makes people scream. So let's see some of the things people have tried, which is available openly so far. Unfortunately, not a lot. Just the only thing I have noticed today is multi-threading. It only appears since last month on YouTube. And then what about multi-processing? Probably not a good idea. But the only available pretty comprehensive thing right now we can find openly is about TaskLit library. So this is an open source library on GitHub, which is created by some of your fellow Europeans, maybe in Holland. So we will also investigate how that works. But today, our proposal is to write a Streamlit RQ library to improve the experience even better. So our ongoing Streamlit RQ work, including we will add the feature to allow any user of the library by just need to write the user-defined function through UI. Because our data people, we should do no more work than that. And we will also add some of the scheduler features we will show everyone later. So let's just briefly see what people so far are sweating about Streamlit online. So we will notice someone in 2022, so it's asking about, is there a scheduler? And then a year later, September 2023, so some people are sweating about, so how can we run a long running tasks with Streamlit as asynchronously? So far, another year has passed. Unfortunately, I haven't noticed any efforts openly yet. So let's just make the world better after today. Firstly, why Streamlit would run into these problems? Let's just imagine if a McDonald's queue is run by Streamlit, what will happen by default? So everyone has to wait for the person in front of you, not only to get the order, but also get the hamburgers or whatever he needs first before you can even order something. So that's what Streamlit is running today by default. So that doesn't look good, right? So let's just see how this works in reality. So please see this GIF. So here the queue starts, and then you choose single-threaded Streamlit, and then you submit your task. But if you notice, the button under submit button is grayed out because Streamlit cannot do two things at the same time. So after you submit your task in Streamlit, everything else underneath is paused and blocked. So you have usually most of the time, when you're using Streamlit to run your OpenAI API request, then you have to sit there with your tireless legs waiting for this Streamlit simple task to finish before you can even try anything else. So that's a really painful experience in my daily life so far, unfortunately, but not after today. Okay. So this is the default code flow will look like with default Streamlit. So you will see this underscore red line here. So this is where you submit your task function. So it can be any user-defined function through Streamlit task queue. And then you see that anything below that is blocked and paused after you submit that red line on your code. So that's just not ideal. So let's see our proposal. So let's do something powered by async task queue. So these are the three main impact factors that we will make all general data practitioners' life easier with this library. So firstly, you can submit your task request through the UI while the previous task ones are submitted and still in process. So you don't have to sit there and waste your life because our data people's time is precious. So with Streamlit RQ, you can do that. And also, multiple tasks submitted can also be completed concurrently at the same time. So it's not just that the requests can be completed one after another without waiting, but at the same time, the tasks that have been submitted and in process at the background can also be processed concurrently. So we will also add the feature that anyone using the library can submit their any user-defined tasks wrapped in defined functions through the UI. So you don't need to write any of the overheads and nothing else. Just write your business logic. That's all you need to do through the library, and it will get it done for you at the background. So how did we get here? So we went through some pain points, but also some exploration. So firstly, we explored how about multi-threading. Then we went to ask, then how about multi-processing? So someone has tried the efforts with multi-threading right now on YouTube last month. It was pretty cool, but we will show you why multi-threading still need the queue. And then we also tried multi-processing, but we will show you So we tried the hard thing, so you don't need to. So we will show that multiprocessing with Streamlit right now is not available because it cannot write to Streamlit right now. So because the whole point of Streamlit is you interact with the UI, but anything returned from multiprocessing library cannot write to Streamlit UI. So that's a pity. But there's a very well-created library called Tasklet right now. It's using a sub-processing library in Python, built-in library, but it only works with command line requests. So you can only schedule the task through this library for command line prompts. But our library will show that you can actually define any function or any task you like and submit through the library. So let's just use a comparison table to see what are the aspects of these three ways that are different. So firstly, a lot of the time, so let's just ask, so how many of you are BI data analysts now? Maybe show a round of hands. Okay, perfect. So how about data engineers? Okay, a little bit more. So then who are the rest? Okay, oh, the cool kids, awesome. Yeah, that's why we are all here today, right? Okay, so some of the time data engineers, so a lot of the work are involving the I/O tasks, right? So downloading stuff or pipeline stuff, or for the data analyst, for the data scientist, a lot of the time the tasks include a lot of computation intensive work, right? So for multi-threaded work, I/O bound is better, but once you get to the data science task, let's say that you run a computer vision or PyTorch model, then you would be in pain. But multiprocessing is better for CPU intensive work. So, but the best thing that we find is with distributed worker queues. So the same thing for multi-threaded, it's concurrent, but it's not really parallel. But for the latter two, they're both parallel. And distributed worker queue, it can even distribute CPU intensive tasks to multiple different workers. And we call that microservices. So it can be scaled horizontally very well. Another difference is with the memory use. So for multi-threaded work, different threads, they actually share the same memory space, but for multiprocessing, they're not. So if any of you are going through interviews later, I found this is actually, well, according to YouTube, this is a common interview questions for fan company, if that even helps. So here is some graphs that will show you actually how this workflow are different. So you can see the top left, it shows multi-threading process. So you can see that it's not really parallel, right? So when the first main thread starts, the task one thread, so you can imagine in your Streamlit code flow, and then while it's sitting there waiting for your app to downloading something, then it starts a second task in a different thread, right? So that's how you define it in your Streamlit code. And then it also, both threads are going to be processed and then hopefully completed around the same time. And then, but you can see the bottom left are multi-processing. So it's in real parallelism. So both process, they actually started at the same time. So that's the difference between multi-threading and multiprocessing. So also this shows you on the right-hand side the difference, how the different two ways are using memory spaces differently. And then so let's see how multi-threading work in Streamlit first. Okay, so let me start. So you can see that we have two tasks. So we want Streamlit to run both tasks concurrently. So you don't have to wait for the first task to finish before submitting your second task. So here you see that, so the two different tasks, so one, it can be sleeping, or it can be any function that you define that is I/O intensive. So for example, downloading a website or uploading something. And then the second task, it can be also some other task, which is I/O bound type of task. So you can see that after, so I'm gonna play again. So you can see that after you submit the first task, and then you don't need to sit and wait there, and then you can immediately, while background is doing its work, then you can immediately submit your second task. Now it starts counting, right? So this saves a lot of time and definitely improves your life quality, so you can, go home earlier. And then this one, so this slide shows you how you actually design this multi-threading code flow in your Streamlit. So you can see that basically you use the multi-threading library in Python, and then you wrap your two tasks and then in different thread wrapper, and then you start them whenever it is submitted. And so this one shows you how to do multi-processing in Streamlit. As we mentioned earlier, multi-processing right now in Streamlit is not ideal, because even though it can submit back-end task, but it's not good with returning any feedback to the Streamlit front end, because that feature is just not available right now with Streamlit. So if you just want to do some low-key, low-profile background work, yeah, sure, you can use this. But if you want to do it, just show off to your managers, probably this is not a good idea with this library. And so this one we will show you, this is another available efforts right now on open source library. It's called TaskLit. So it's using the also a kind of multiprocessing library for command line subprocess. So this is how it will work with TaskLit. So you can see that you enter, right? So you can enter any command line in the UI there, and then you can submit the task through this UI, and then it will execute for you in the background. So, but the limitation is that you can only execute command line prompts here. But we want to be the real cool kids, right? So we want to be able to actually do anything, just command line work. And so we will show you how multi-threading, why multi-threading need the queue, right? Because as we mentioned, different threads, they share the same memory space. So therefore, different threads, they actually access the same variable at the same time. So therefore, there can be data races, there can be data conflicts, and then there can also be duplicated operations performed on the data variable. So therefore, the data could be corrupted. So therefore, we need the thread-safe queue to solve this problem, because when threads switch on and off is beyond our control, and it's up to the operating system. But with a thread-safe queue, this problem can be solved, because then multiple different threads, they can access data in order, one at a time, when consuming the data. And also the task queue, the manage of the task queue, it can also avoid conflicts of different multi-threads accessing the data and performing the operation. And so this is how the benefits of choosing a Redis queue for this purpose, for Streamlit. So Redis is a in-memory data structure store, and it can also be a database, cache, and a message broker. So Redis server, it achieves concurrency through multiplexing mechanisms and event triggers. So from Redis data structure, so there's Redis task queue, and it includes receiver queue and also worker queue. So it's a thread-safe queue in the sense that it won't be corrupted if multiple workers are pushing or pulling from the queue at the same time. So the worker queue also can automatically detect when to take a task currently in the queue, just by setting up a listener to the queue, and task will not leave Redis queue until it's completed. And also, it has the feature of atomic, in the sense that it won't be corrupted if message workers are also pushing to the queue at the same time. So another benefit of Redis Queue is it's really simple, because there are many different other queues available in the market right now. So there's salary queue, there's other queue, but the benefit of Redis Queue is it's really simple development. So therefore, a lot of people actually switch for Redis Queue for the simplicity of it, because the whole point of Streamlit is, the philosophy is simple development, right? And so this is how we structure our library code. So firstly, you see that we have a Redis server, and we have the main Streamlit app controlling the flow. So after the user submit the request through Streamlit main app to the Redis server, and then the workers then will be spin up to pulling different tasks from the Redis server queue. So in our co-organization, so firstly, we have a module called scheduler. So firstly, we have a function called start scheduler process. So what this function does is it starts the Redis server, and then it also constructs a queue connecting to the Redis server. And then it also spins up another multi-process, a different process that actually start the background worker at the background. So therefore, we are using a multi-processing here to handle these different two processes. And for the worker to be run, we are setting up the worker listening to the Redis connection, and for the task to be pulled automatically and for execution. And this, and then the second step in the scheduler module, so we write an in-queue process. So this is where the task is being submitted through the Streamlit app, and then letting all the configuration to do its work. So as we see, as we have seen this table already, so we also write another task module. This is where the add-on feature that that allows the user do not need to care about any of the overheads, but only write the business needed user-defined function. And so this is how we structure the code directory. So you can see that we have a DB, so that handles the app and talks to the database for all the data. And we have a queue manager, so that's the module mostly handles the management of all the queues. And the scheduler is just the overall, like maybe the director that is to schedule all the different workflow. And then where the task is where the user could modify that you can just write any of your user-defined function that is business essential to into adding this task module and then submit through the rest of the workflow for execution. And so as we mentioned, the two main features of Streamlit RQ is that it can help to unblock the your Streamlit app. So therefore, nothing is in pause. So the whole workflow can actually be executed smoothly, and it can also complete multiple tasks concurrently in the background. So we will see how everything is put together in place for this to work. So let's say this is a fast ordering system in Streamlit, and we want it to be fast with a Redis task queue. So you can see that in the database on the right-hand side, we already have some tasks that are processed. So we have 4 different tasks that we can submit. And then so we see that one person already submitted the first task, and then 3 other people came and then submitting their task almost at the same time. So we can see that firstly, the first person, the task gets added on the queue, and then you can see that all the other later 3 tasks are almost added at the same time also in the running queue. So here you can also click update button to see how your tasks are doing. So here we actually use another cool feature that Streamlit just developed. It's called fragment run, because we know that Streamlit, one of the pain point is also whenever you click rerun, it's just gonna rerun the whole thing regardless how you want to do it. But this new feature called fragment rerun, so it lets you to tag one front end feature to only one section of your app related to one background function. So this update button, so therefore it doesn't rerun the whole app, and it only runs the database or the status update of your app. Just imagine when you go to a McDonald's queue to order something, you have a monitor screen. So that monitor screen update, whenever you click your button there, it doesn't reset everything. So it only resets or updates anything on that monitor. So we can just take a look again how this queue runs. So firstly, when someone actually comes to the queue, so they see that someone already finished some orders. And then remember, there are two main features we want to demonstrate to complete here. So one is you have a person reception, right? And then you have some other workers, in McDonald's working at the background. So this is already a separation of labor, right? So so this is another, this is one level of separation here. So another one we want to show is so it's taking order for in one process, but also processing the orders in another process at the background. So another feature we want to demonstrate is after you submit the task, we want to show that the different tasks, they can also be taken care of concurrently at the same time. Because if you see that the first person orders something, order the task first, but then there are some other tasks, the later tasks are about submitting the same time. So therefore, when you update your queue, so you can see that the first person's order is completed first, but then the later two tasks are almost completed at the same time because they are submitted at the same time. So this is a demonstration that you don't need to wait for the task to finish one by one at the background. So you can scale up the workers at the background. So as long as the tasks are submitted almost at the same time, then they're also completed almost at the same time. And then, so here it demonstrates these two main features in this app that sees everything putting together. So yeah, that's pretty much our demonstration today. So any questions?